recording. Oh, yeah, now we're recording. How's everyone doing?
Good. How are you?
Good. Good. Yeah.
Besides being blurry.
Yeah, I don't know. I I don't know what's going on. So, did we have any questions about the stuff?
Um, I think I'm good. I don't have any questions.
Yeah, I felt the same. What about you, Michael?
on on the homework.
Yeah, the prep.
It's okay.
It was okay.
All right.
I was more pissed off about the test.
Oh, yeah. That test was interesting.
I thought
You guys do good?
100%, and I got 86%. Like,
Yeah, I got like 84, I think.
Yeah, that's what I got. I thought I did really good, and then I was like, 84. Dang.
Yeah, I don't know if it was like rounding wrong or what happened,
I
but
don't know.
what drives me crazy is that we can't even go back and look at what we did wrong.
you know,
Yeah.
maybe once um, the test is closed, we can do that.
I checked this morning after it closed, though. It didn't let me.
It still wouldn't let you.
Yeah.
Yeah, for Mike. Yeah.
Anyway, should we get started?
Yeah, let's do this.
All right.
It's not 30 questions like last time.
Oh, thank goodness.
Here,
Oh,
one second.
21.
Just gonna get my calculator and notebook.
Oh, that helped.
All right, are you guys
All
ready?
right, for number 3. Yeah.
Okay.
The hypothesis test consists of 2 hypotheses, the null hypothesis and the alternative hypothesis. Which one represents the status quo? That's the null, right?
Yes.
Null hypothesis. That's what I got.
Which which hypothesis involves equality? I'd say. hmm,
Yeah, because
Sorry,
the
what?
null is just a general statement or default position.
Right.
Yeah.
So you'd say Linol.
Yeah.
Because I was never really understood what they meant by equality. It's usually, like it's one or the other.
Yeah, so like with this reading that we did, a lot of it was the average temperature or the mean temperature of an adult human
Right.
is 98.6. And so that's the null hypothesis,
Right.
saying this
It's
is
What we
what
believe
it
is
is.
true.
okay. So
The
what it is?
other
Okay.
one, the alternative, is the one that's like, I don't think it is, so it wouldn't be equal to that.
Hmm.
So, all right. Blaine, do you want to take this one?
Yeah. Which hypothesis involves equality? I want to say that's the true hypothesis. Because
I
when
thought
it,
we
what was that?
there is no true hypothesis.
Or, well, yeah, but so then it's the alternative hypothesis.
No, it's the null.
Are you sure? Is it really?
Yeah,
Oh my goodness. I thought there
yeah.
was a true hypothesis if it, like, when you proved which one was true.
I I don't remember reading about a true hypothesis yet.
Oh, okay.
But I'm looking at the reading right now, and the null hypothesis has the equal to, and the alternative has the less than, greater than, or not equal to
Oh,
signs.
I should read more carefully.
Yeah. Okay, so number 5, the p-value is the probability of obtaining a sample statistic at least as extreme as the one that was actually observed. For this information, answer number 5. When computing the probability, which hypothesis do you assume to be true? You always assume the null hypothesis to be
Yeah.
true until you prove it to be wrong.
Suppose the null hypothesis is mu equals 10. Which of the following represents the alternative hypothesis for a two-tailed test? Okay, so for two-tailed test, you're going to have that it's not equal to 10. So,
Yep.
Yeah, it equaled 10, right?
because
The null equaled 10.
Yeah.
So,
It's the alternative that doesn't equal 10.
exactly.
you're not saying that it's above or below, you're just saying it's not that.
Yep.
Wait.
All right, who wants to take 7?
Which of the following represents the alternative hypothesis for a left-tailed test? You're saying that mu
Sorry, you cut out. What was that?
I'm saying it's going to be mu is less than 10
Yeah, that's what I think.
Yeah.
tailed, so
And the right-tailed then is going to be greater than 10 on number 8.
Mm-hmm. And then the outcome of the hypothesis test is determined by comparing the p-value to the level of significance, or alpha. Use this information for questions 9 and 10. Which relationship would result in failing to reject the null hypothesis if the p-value is less than alpha?
How'd you get that one?
Oh, wait. Failing to reject. Sorry, it's greater than alpha.
Greater than alpha?
Yeah, because the next one, when you reject it, it has to be smaller than, so we choose alpha before, so it's usually 0.05. And then the p-value you find with the z-score, and then do the template, or like the applet thing, and find out if that's less than 0.05. And if it's less than it, we reject the null hypothesis. But if it's greater, then the opportunity to randomly select the null hypothesis is larger than the level of significance.
Okay. That makes sense.
Okay.
All right, I'll do number 11. An insurance
All right.
company is reviewing its current policy rates. When originally setting the rates, they believed that the average claim amount was $1,500. They are concerned that the true mean is actually higher than this. Use this information for questions 11 through 12. 11. Which of the following would be the appropriate alternative hypothesis for HA? So that would just be what they... Wouldn't that be the... that they believe it's actually higher than 1,500?
Mm-hmm.
Okay.
all right, I'll take 12. Which of the following would be appropriate null hypothesis? Well, the null hypothesis is status quo, which was the 1,500 they believed the average claim was. So they would be, the average claim amount is equal to 1,500.
Yeah, that's what I think.
Mm-hmm.
All right, for 13, we're using the information for 13 through 15. The insurance company randomly selects n equals 40 claims and calculates the sample mean of x bar is equal to 1650. The insurance company assumes the distribution of the sample mean is normal. Is that a good assumption? And I said yes.
Yeah, the mean's going to be the same.
Mm-hmm. And what theorem or law justifies your answer? That'd be the central limit law.
Okay.
Okay.
All right, so for 15,
Yeah.
I just quickly looked that one up, and it's Z.
It's
It's Z. Yeah.
Yeah, I was just looking for that.
Yeah, I just did control find,
Mm,
and it brought me up to many moments that were like the test statistic for this one.
4.2.
Yeah, it kept saying like the test is statistic Z, test statistic Z, and then like at 4.2 it says Z is equal to, and it gives us how to find the Z score. So
Awesome. The historical mean of sales receipts at a grocery store is $150 with a standard deviation of $40. The store manager suspects that the average has decreased. She sets up a hypothesis test with the following hypotheses. And the null is equal to $150 and the alternative is less than $150. She will use a level of significance of alpha equals 0.05. She then takes a simple random sample of 36 sales receipts from her store and computes the mean to equal $144. Use this information for questions 16 through 18. What is the z-score associated with this test?
Negative 0.9.
that's what I got.
1 second. I'm going to do it real quick. Negative 0.9, that's what you guys got?
Yep.
Okay, awesome.
And then for 17, you just plug that into the applet. And since it said less than that, you use the left tail. And I got 0.184.
Yeah. Right. What inference would you make about the null hypothesis for this problem? Let's see. So the p-value is greater than the 0.05. So we're going to fail to reject. Right?
Yeah.
Mm-hmm.
All right.
Because if the p-value, wait, so just explain how we got that one again. I just want to make sure I'm understanding it.
So the p-value, you put the z-score into the applet that we have, the probability applet.
I'm talking about 18, like,
Oh,
yeah, because the level of significance is 0.05, so I just want to make sure I'm understanding. Because we got a p-value of 0.184, it fails to reject the null hypothesis, right?
because it's greater than 0.05.
Okay, so she's trying to find something that would be less than that. Is that
Yeah, like if you were to randomly take some sample,
Mm-hmm.
what are the chances that it would be within this null hypothesis? And
Okay.
if it's below 0.05, then you reject it. But if
Uh,
it's greater than 0.05, you fail to reject.
okay. All right, I just want to make sure I'm understanding that right.
Yeah, I think we'll get a lot of those kind of questions on the test.
Yeah, I bet.
You understand that?
Okay, for 19, there are two types of errors that can be made when performing a hypothesis test. Which one involves rejecting the null hypothesis when the null hypothesis is true? That would be type 1.
The researcher decided that instead of using the level significance of alpha equals 0.5, you will use alpha as 0.01. Which of the following will be true? Probability of
Huh.
I would say the probability that the null hypothesis is true will decrease because you're changing the parameters. You're giving yourself a lot smaller.
But wouldn't that increase the probability that it will be true?
The probability
Although,
that the null hypothesis is true will decrease. Wait.
I don't know about that, because if it's true or not, it still has the same probability. It doesn't matter what alpha is. Like the p-value and alpha only go together when you're trying to figure out if you should reject or fail to reject it. So I don't think the truth of the null hypothesis has anything to do with that.
Oh.
Personally, I think it's either two will increase. I'm just trying to figure out which one.
Yeah, that's what I was thinking, but yeah.
I don't know. I don't know what the alpha has to do with type 1 or type 2 errors, though. That's what.
Well, the alpha tells us the level that it needs to be if we're going to fail to reject or if we're going to reject the null hypothesis. So since this alpha went down, we're going to fail to reject a lot more of the null hypotheses.
Then that would be type 2 error.
In error, though, you're just changing the parameters of how tight of you want to change something or to reject it or not.
Yeah, if you look in the reading, there's like that little chart. It's in section 4.5 with the type 1, type 2 errors. And it's talking, because like when the alpha gets smaller, it's going to be harder to fail to reject the null hypothesis, right? Which that's going to be lead to more of a type 2 error if you.
Yeah.
Okay.
Because the closer it is to 0, the closer your alpha is to 0, the less of a type 1 error you're going to get.
Yeah.
I'll need to study that one more.
So if alpha equals 0.05, we need to compute the probability of getting a type 1 error.
I don't know how to do that.
I don't either. Well, I'm looking on here, and it says the most common value for alpha is 0.05. That is equal to 1/20th. So when the null hypothesis is true, there is a 1 in 20 chance it will be rejected. So wouldn't that just be
0.05?
0.05?
I guess. I feel like that's too simple, though.
I know, same here. Here, I'll submit it and see what it says. Okay, yeah, we did get 21 is right. We did miss one. We missed number 6.
Number 6.
And so which of the following represents the alternative hypothesis for a two-tailed test?
It's not, mute is not equal 10?
Well, it's alternative. We misread that. Wouldn't it be not equal to 10? Because the null equals 10.
Yeah.
It's
Did you put mu is equal to 10 or mu is not equal to 10?
I put equals to 10. That's my bad.
Okay.
I don't know what I was thinking there. I read it wrong, but.
Sweet.
Awesome.
Hey,
All right. Okay. Don't forget. I'm gonna. Oh, weird. Sorry. Don't forget that I'm going to post the link to this and then comment under it on the discussion board to say that you were there.
Okay.
Where's the discussion board, real quick? Because I can.
Okay, so it's called the collaboration board. If you go to lesson 9, you'll see the individual preparation, group meeting, homework. Right under that homework is The group collaboration is what it's called.
Okay.
Did you find it?
Mm-hmm.
Okay, great. Thanks.
All right.